Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
All right, Lino. Here we go.
Wow. Okay.
I'm always worried when it comes to talking about science without Caroline.
I know. Caroline, encourages us. She says that's great things, but I know in her mind she'll go, boys, what have you done to the science section?
What have we done to it?
What have you done?
Yes.
I know we love you, Caroline, and you love us. I know we love you, man.
So I'm going to stick with something that we're comfortable with, and that's space news. And
cool. Yes, Judas.
And actually, an event that I was really, really excited about that happens. Started on Christmas night here in Australia. So it was late, just before midnight here in Australia, Christmas night, and I thought it was great. And it was the launch of the James Webb Space Telescope. And
hold on. I must admit, it does look like a very big honeycomb.
It does, yeah. Like the mirror, is a massive
it's
mirror.
So cool.
Yeah, is it 6.5 meters mirror? The mirror is, which is 6 times. That was my first talking point there. 6 times the size of the mirror of the Hubble Space Telescope.
Wow.
So this thing is a beast.
It is.
The solar sail or the solar covering there is the size of a tennis court. The sun shield.
Goodness me.
Which keeps all the equipment really cool. This is a really serious telescope, and one that I think, this is my big call for the year, that we should pay a lot of attention to, because this is going to open up discoveries and new scientific knowledge that humanity has not encountered before. It's going to deepen our understanding of the deepen our understanding of the universe. And so I just wanted to share some really interesting things and then list some resources that people can do some further research of their own on. So a couple of things. So first of all, I've talked about the size of the mirror. So the mirror is this sort of gold-coated mirror made of sort of hexagonal shapes all put together, and it makes a 6.5 meter sized mirror to enhance the imagery that they can collect. And each of those mirrors have little motors behind them so they can be adjusted. So it's not one giant mirror with one movement. It's when it's all put together, it is one giant mirror, but each of those sections of it can be adjusted slightly as well where needed. The James Webb Telescope can do is detect light from galaxies which have formed 13.5 billion years ago. So,
oh my goodness me!
And here's the kicker. This is only 300 million years after the Big Bang. So that's a long time. But in the age of the universe, that's nothing. Like that's really young.
Well,
no, it's not nothing. But it's very young.
Yeah.
So if the universe is 13.5 billion years old, and we're going to be able to see the light from galaxies that are only 300 million years after the Big Bang. That's massive. Like that's like this is very, very early. People have talked about this being able to look into the past. The young universe. Wow. So there are lots of discoveries there. So some of the questions it wants to address is, how did early galaxies form? So to be able to look at the formation of galaxies from a long time ago. Are there chemical building blocks in the atmospheres of other planets? So to be able to detect those as well.
Yep.
And is our solar system unique, or are there solar systems like ours? So these are really important questions to answer. As we know, and so Lino, we were you and myself and Jared's families. Remember, we went to a little place called Lurg.
Oh my goodness!
Over the holidays, pre getting COVID.
Yeah.
And we hired a holiday house there for almost a week.
Nice place.
And
awesome
do you remember
place.
that night we went stargazing?
Oh my goodness me!
And there's no light pollution because there's no street lights, nothing. It's pitch black outside because we were in the middle of a rural property, and there's no streetlights or anything. It was
Streetlights and everything, you're
farmland everywhere as far as the eye could see where we were.
Exactly.
And when we all looked into the night sky,
oh my goodness me.
it was so populated with stars. And galaxies,
planets,
and it was amazing to look at. It was just so stunningly beautiful. Like
it was.
And you could just notice the detail of the night sky so much more than if you do it from your backyard.
Exactly. It was.
And we were talking about, we had a conversation that the light that we were looking at is from the past. It's it's where those stars and galaxies and everything were possibly millions of years ago, depending on how long it takes for the light of that star to reach
us.
Yeah, like traveling at light speed and all that. So the James Webb Telescope is going to be looking at galaxies. That this light can look into the past, as it's described. It's going to look at the light from galaxies as they were, billions of years ago. Now, Caroline can explain this better, but this is based on the idea of redshift, and I'm not going to explain it because it confuses me. I'll leave it to Caroline. So, Caroline, make a mental note to explain redshift to our. But the idea of seeing light from an object, from those millions or billions of years ago. Because of how long it takes for that light to reach, our eyes, the Earth, the telescope, whatever.
Exactly.
So those are the fundamental questions it's going to explore. I love this one about, is our solar system unique? Because I watched this great documentary on other solar systems and exoplanets and things like that. And our one is unique in the sense that apparently our Jupiter is in the wrong place compared to where the Jupiter-like planets of others solar systems are. So generally, and you can Google this, everyone. This is a true thing.
Whoa.
The Jupiter-like planets in other solar systems are actually the first planet after the star, the sun of that solar system. And they call them hot Jupiters because they orbit closely and they spin very fast. So they call them hot Jupiters because they're closer. So our Jupiter is in the wrong place. Or is not in the same place that's found commonly in other solar systems.
Solar systems.
Yeah, and I know I'm explaining that in a very basic way because there's a lot more science behind that. But it makes us unique, and Jupiter actually in our solar system protects us from a lot of the space junk and the rocks and everything. That could potentially collide with Earth.
Collide with Earth.
It's like a bit to say. Yeah, someone describes it as like a vacuum cleaner for our solar system in one sense.
Yeah.
So So that's a really important question. So are there solar systems that are similar to ours somewhere out there in our galaxy and beyond our galaxy as well? Now the James Webb Telescope was too big to fit into the standard fairing of any rocket. So it because it's the size of a tennis court when it's completely unfolded, there's no way you could store it in a rocket. The fairing of those two covers at the top of a rocket where you put your payload and then open and deploy and whatever else.
Exactly.
So it's not going to fit anywhere. So they basically designed it to fold up like an origami, inspired by origami. Yeah. So now I've got to say, thousands of engineers from the United States, Canada, and Europe worked on this and on the different components and everything. And the unfolding and opening up after it was launched was a engineering marvel because lots of little bits and pieces had to move around, and lots of components had to open and unfold and assemble. And as each time this happened, it would take hours.
Yeah, definitely.
Now, if you're here on Earth, you could use your hands and just fold something open, done, right? But because it's hurtling away from the Earth, and we're not going to be able to send anyone to repair it if something goes wrong. They had to go through this process of getting it ready so meticulously. And in fact, the James Webb Telescope, the design started in 1996.
Whoa, what's that?
So was it 25 years?
Wow.
Is that right? Someone else can maths me on that. That's why we need Jared. He's the maths guy in this group. About 25 years. Yeah, to go from design to build to testing and launch. Yeah. So it was designed to fold up and fit into the fairing of the European Space Agency's Ariane 5 rocket, which is like a heavy-duty lifting rocket. Yeah, an amazing rocket to watch its launch because this thing is massive. It's powerful and it just shoots off the ground. It's like it's got no time to be on the ground. It wants to get to space. It's,
cool.
Yeah.
Oh, wow.
And so the launch apparently was so successful as well that it was placed perfectly into Earth's orbit to leave the orbit and head out into further into our solar system. It was so perfectly placed that the engines weren't really needed for massive corrections.
Oh,
that,
cool.
That the telescope will now go way beyond the 10 years that
10 years.
that was expected at its
Oh,
lifespan.
wow.
So it will be able to stay in its orbit, and I'll talk about the orbit later on. Well beyond what was expected. So they'll be able to collect lots of science for a lot longer, which is awesome.
Cool.
And 10 years really, when you think about it, is not a long time in research. Yeah, because the universe is so big. You can't.
It's massive. It would take a lot more longer than that.
Yep. So go on.
Wow.
Yep.
I was about to say, Liz, can you imagine that you've been working 25 years on this project? Well, that is if you've been in that job for 25 years.
Yeah.
And I would be so teary.
Yeah, I would too. I'd be celebrating like crazy.
Celebrating, seeing this thing fly up in the air, able to find out a lot of information about the universe.
Yeah.
And it's able to, you can imagine that you've done all the drawings, all the technical things, and making sure this thing unfolds properly.
Millions of hours of design and preparation.
Trying to
building.
make sure building, and then you find out that you go up there and it's perfect. He doesn't have to. What do you call it? The rocket's lens. He didn't have to adjust.
No,
where
it was
he had
perfectly
to go.
placed.
Perfectly
where
placed.
It needs to be. Yeah.
And boom, and it's gone.
Yep.
And it's like saying goodbye. Not goodbye, but saying good luck to a.
Well, it's like one of your children in a sense.
Exactly. I was about to say that.
Yeah, if you were there from the start to the end of that process, it's like sending a child away.
A child away.
Yeah, out into the world.
Into the
universe.
Into the universe. Out of space.
Yeah.
Out of space.
Absolutely.
It'll be. Oh, that's awesome. We'll see how James Webb. I'm assuming that's the guy who actually really designed the thing.
Now, I probably should have done some research beforehand, but James Webb was a space scientist. And I'll get Caroline to fill in the gaps in the next episode.
Sorry. Sorry.
No, I didn't do my research. I probably should have done my research on the naming, but I'd planned to talk more about the satellite than its history. But cool. The telescope. But we'll fill that in a future episode. Yeah. So it took 3 weeks for it to unfold and open up completely.
Definitely.
And that was all done remotely. So they had to unfold, send all the signals for it to do this, to do that, and to make sure it works. So I'll just go through the process of the opening up very, very quickly. So we were fortunate enough to see this one in the live launch, which was cool. 31 minutes after it was launched, the solar array deployed. They opened up, so you can actually see it. The satellite, the telescope moved away, and you could see the footage, and it's beautiful footage. And then in that same moment, as it was moving away from being deployed, the solar array opened up, which was really good to see.
Cool.
2 hours later, the high gain antenna deployed, and then on the third day, the sunshield palette extended. So the sunshield palette is like the surface that that's used to stretch
out
and tension the sunshield.
Yeah.
So that it's like a frame for it. So that opened up.
Cool.
After 4 days, the tower assembly deployed, and so this is the middle section where the mirror is folded up. So it extended, basically. It moved up. So that had to happen, so that eventually the mirror could completely open, unfold. Yeah. So after 5 days, the momentum flap. So there's like a flap on one of the far ends of the telescope, deployed successfully. And then the sunshield membrane opened up as well. So this was like the cover so the sunshield could deploy. On day 6, the sunshield opened, which was a very long process. And this would have been the most nerve-wracking part, I reckon. So it's the size of a tennis court. It looks like almost like a giant, not triangle. What do you call it? That other shape. Anyway, it looks like a giant kite. Anyway, so it had to tension, which means it was stretched out, and it's got several layers. So it had to open up as well.
Oh yes, yep.
So then on day 10, the mirror support structure deployed. So this is a structure that opens up and supports the mirrors. And then on days 12 and 13, the two sides of the mirror opened up and connected into this giant 6.5 meter mirror array that it has. And then on the 24th of January, which is 1 month after launch, the telescope successfully arrived at the Lagrange point 2, which is 1 million kilometers, I should say, away from Earth. So it's 1 million kilometers away
Ooh.
from us.
Jeez.
And basically it's going to orbit the Earth and the sun at that 1 million miles, making its orbit and then using its engine for course corrections from here and there. But again, because the engine didn't have to use a lot of power and fuel to make any course corrections from the launch, because the launch was so perfect, that engine has a longer lifespan, which means more data can be collected.
Yeah, more data can be collected. Yeah,
which is great. So so that's all I'll say about the James Webb Telescope for now, except to say that we're obviously going to be following its progress now. At the moment, it's in its orbit. The equipment and cameras, it's got these big infrared cameras. It's got a whole lot of them, which can take photos or can observe multiple objects at once, so hundreds of objects at the same time, which is awesome as well. So
it's one expensive camera, man.
These cameras, this project I think went into the billions, or this was an expensive over budget project.
You definitely can't buy
really
that
awesome
a
as
camera
well.
from Ted's cameras, ain't you?
It's more than Ted's cameras. Yeah, this is more than the lens that you bought for Bernie the other day. Don't worry. But this, basically, it's got a group of different kinds of infrared sensors and and cameras. And the important thing about this is that they can see through nebulas and through dust clouds and beyond into the galaxy beyond to be able to capture light from stars and galaxies and other objects that are out there that we cannot see with the Hubble Space Telescope or anything else at the moment. So this is one incredibly sensitive telescope, and what like I said, I can't wait to see what it brings back and what discoveries we find there. Yeah. Yeah, so that's the James Webb Space Telescope, and I just wanted to bring up another couple of very quick space stories. So the first one is I hope no one's going to be planning on being on the dark side of the moon anytime in March, because as this headline says, I think this is a bit clickbaity to be honest, but it says "Out of control SpaceX rocket on collision course with the moon." Now that gives you the image that there's some rocket flying out there under power, with its engines lit, and it's going to collide with the moon because something went wrong. Now, what actually happened was a Falcon 9 booster. So the booster is the first stage, which pushes the payload and the second stage into space out of the Earth's gravity well. And then what happens is the first stage separates from the second stage. In SpaceX's case, it usually comes back to Earth and lands. That's what they do now. Or in a lot of other space agencies or companies, the first stage will separate, and then it will burn up in the Earth's atmosphere. That's what happens in other companies. So SpaceX now recovers its first stages. They come back to Earth and land, which is always really cool to watch. But this one was deployed in 2015, and I think this was one of two possibilities, because I didn't actually do my research on this. Either this was before SpaceX was returning their rockets and recovering them, their boosters, or sometimes the payload is really heavy. Like the weight, there's more weight. So they have to keep the booster running for longer. To the point where it can't be recovered. So it's basically shot out of Earth's orbit as well. And that does happen, that does happen sometimes where the payload, it's because of the size and weight of the payload, it's not possible to recover the booster. So SpaceX hasn't done that in a long time, but that was sort of the go with that. So it launched in 2015. As part of an interplanetary mission to send a space weather satellite on a 1 million mile journey. So again, this was another satellite that went to the Lagrange point as well. Cool. So obviously it wasn't just a low Earth orbit situation. So the booster did have to do more work to get it out of the Earth's gravity. But after the time of completing the long burn of its engines and sending the NOAA's Deep Space Climate Observatory on its way, the rocket's second stage became derelict, so they discarded it, just sent it out into the solar system. So I'll cut the story short, and if people want to read the article, they can. Basically, because of gravity in the solar system and the way things work out, sometimes our space junk comes back. It happens. All right, it does happen. We've had old probes that have been gone for decades that will not come back to this close, but come back.
Yes, definitely.
So what's happening now is that the observers have mapped out that it's been on a chaotic orbit, so it hasn't been like in a stable orbit. from wherever it was, and there's about 4 tons of space junk from this
4
first
tons?
stage. Yep.
That's a lot of
And it's going to collide with the moon at a velocity of 2.58 kilometers per second, sometime in early March. Some are saying on the 4th of March. And in this article from The Guardian, there's a link to the blog post which goes into some really deep science about why this person says March the 4th. Sadly, if you wanted to observe it, it looks like it's going to hit the dark side of the moon. So
we won't be able to see it, definitely.
So we're just going to know it happens, but we're not going to see it. Maybe someone will catch it on its way to the moon, but we actually see the collision. Yeah. But I think it's going to be a bit of an anticlimax. I think it's just going to be like a thunk, and that's it. You know, it's but pretty, like pretty interesting thing anyway. And he said, one of the scientists, an observer, he said that the event will allow for observation of subsurface material ejected by the rocket's strike. And he's saying that he hopes it hits the moon, but he said, we already know what happens when junk hits the Earth. There's not much to learn from that. More than anything, it's interesting. Yeah.
Okay.
Yeah. And lastly, for our science topic, I just wanted to mention that this is a big year. Every year is a big year in spaceflight. But this is a really big year because there's going to be a couple of firsts. So the first thing is that one of the big awesome first is that SpaceX's Starship is slated to launch at some time this year, and this will be its first test flight to orbit. So if anyone's been watching any of NASA space flights live videos and their updates, and also there's a channel called Marcus House. And he's an Aussie, Tasmanian, and he also does an update on space news, like a 20-minute update every weekend. So you can see like what's been happening. And a lot of it is SpaceX because SpaceX is doing all the big stuff right now.
It looks like it. Yeah. Isn't it? Yeah.
And he takes everything and just condenses it into a 20-minute report. And it's good. It's like really high quality. So cool. So Marcus House, if anyone wants to see that. Basically, so Starship will launch on a test. They've had the booster. They've been testing the booster's engines. The booster is a massive thing. It's I think it's twice as powerful as the Saturn V, which, if anyone knows, is the rocket that launched astronauts into space, into the moon.
Wow.
So this is a massive rocket. And so it's going to send a Starship in, and then the plan is that to keep it in orbit, and both the first stage and the Starship second stage will come back to Earth, but they'll land in the sea. So basically, just land on water, and that's it. So this is a test, and we'll actually see how far it actually goes. It will burn up in the atmosphere, or they're not worried if it fails because SpaceX has a different approach where failures and things going boom is part of the way they operate.
Part of the testing subject.
So it's kind of fun in a way watching things explode when they're testing. So yeah. So it's all part of it, and they basically fail towards success, if that makes sense. They learn from every failure, they collect the data, they redo things, make it better until it all works out. Yeah. So that's the first one. The second one is that NASA's Artemis mission, and this is the mission to return people to the moon. So the first Artemis rocket is going to launch this year, and I think February or March is when it's slated for. So it could actually be really soon. So this the launch of the Artemis rocket, it's going to be an unmanned launch. So there'll be no astronauts on this one, but it will have the full configuration of 2 boosters. The big fuel section in the middle there, as well as the capsule where the astronauts. I think it's called a Centaur, and I could be wrong about that. But the capsule where the astronauts would be sent to the moon, the whole lot. All the equipment's going to be there. The idea is to launch this and get it to the moon and back again. So the test flight. And if that all goes well, Artemis 2, I don't know when that's going to be, but Artemis 2 will be the mission to send people to the moon.
Actual physically. Yeah. Yep.
Yes.
Wow.
And Starship is actually a key component of that because Starship is also going to become a moon lander. Part of the Artemis mission is to actually build a space station in orbit of the moon to use for landing and recovery of people who have landed on the moon. So
goodness me,
this mission, the Artemis mission project is amazing. And so if all goes well with this launch, and let's hope NASA's launch does go well because it's expensive and over budget in a big way. So let's hope it does go well. And there'll be some amazing insights that come from that too. And
Yeah.
lastly, this is not a first, but we haven't seen a super heavy launch in a long time from SpaceX. So this is basically 3 Falcon 9 boosters
Goodness me.
strapped together
Whoa.
to launch a massive payload. And those
Wow.
launches are just something to behold, because not only is it the launch, but it's the recovery of the 3 boosters. All 3 boosters come back to Earth.
Oh my goodness.
2 of them
me.
land next to each other, and 1 will land in the ocean. And it's always an event when they have a Falcon Heavy. So there were no launches this last year for a Falcon Heavy, but I think there are 3 or 4 slated for this year. So it's always an event, and I can't wait. And
Wow.
and, yeah. And to my colleague from work who is listening, I'm going to complain again about rocket leave. It should be a thing, and I want leave so I can watch these launches. That's all I'm going to say about that. All right. So that's our science for the week.
Rocket League.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest.